Okay, this video is over lesson 5.8 and it's talking about using the quadratic formula. So this is the quadratic formula, and I made a separate video to explain where this formula came from, but in this video we're going to focus on how to use it. So to use the quadratic formula, it solves equations that are in this form can be solved by using the quadratic formula. So if you have an equation in this form, you need to rewrite it so that it looks like this equation up here. So the first thing we're going to do is we're going to subtract 2 from both sides, and then we will have 3x squared minus 5x minus 2 equals 0. So now it's in this form. And so we can identify that a is 3, b is negative 5, and c is negative 2. And when you have your a, b, and c values, all you need to do is plug them into this formula up here. So let's go ahead and do that. X is equal to negative b is negative 5, plus or minus the square root of b squared minus 4ac. Oops, let's go ahead and plug in those values. For a is 3 and c is negative 2, all over 2a. And then you simplify this formula and you have your solutions. So let's go ahead and do that. Negative 5 is the same thing as positive 5, plus or minus the square root. Inside we have negative 5 squared, which is 25, minus 4 times 3 times negative 2 is 12, times negative 2 is negative 24, and then when you do the minus, we're going to be adding 24. So negative 4 times 3 times negative 2 is a positive 24. 2 times 3 gives you 6. Okay, so let's simplify this even more. 5 plus or minus the square root of 49 over 6. Well, square root of 49 is the same thing as 7, so we have 5 plus or minus 7 over 6. So let's figure out what those two solutions are. 5 plus 7 over 6 is equal to 12 over 6, which is equal to 2. So here's one of our solutions. And then 5 minus 7 over 6 is equal to negative 2 over 6, which is equal to negative 1/3. So there's our other solution. So the two solutions to this equation are positive 2 and negative 1/3. That's using the quadratic formula. Okay, so we're going to do the same thing again here. You need to rewrite it so that it's in standard form. 2x squared plus 6x plus 7 equals 0, so that you can identify your a, b, and c values. After you have a, b, and c, you can plug them into the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's going to be equal to negative 6 plus or minus the square root of 36. Negative 4 times 2 times 7 is negative 56 all over 2 times 2, which is 4. Okay, then if we simplify this, you have negative 6 plus or minus the square root of negative 20 over 4. And so now you see we're going to have the square root of a negative number, which is an imaginary number. So that's negative 6 plus or minus I times the square root of 20 over 4. And you can simplify the square root of 20 also. Square root of 20 is equal to square root of 4 times the square root of 5. The square root of 4 is 2, so it's equal to 2 times the square root of 5. So let's replace I times the square root of 20 with 2I times the square root of 5. Okay, and now we can simplify even further. Negative 6 and 2 and 4, they all share a 2 in common, so let's divide a 2 out from each of those terms, and we have the simplified solution. Doesn't look very simple, but that is the solution to this equation. Has an imaginary number in it. A note on this: it's better to leave it as square root of 5 than to use your calculator, because you have this imaginary number, so an estimate isn't going to do you a lot of good, and the square root of 5 is going to be the exact solution. Okay, so this is a special case. This is a special problem, and we're going to go ahead and solve it now. A equals 1, b equals negative 1, c equals negative 1. And then after we solve it, I'll explain what is special about this problem. Okay, so now you have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, positive 1. Okay, so then you have x is equal to 1 plus or minus the square root of 1 plus 4 all over 2, and this is 1 plus or minus the square root of 5 over 2. Okay, so what makes this a special answer? Well, let's bring up our calculator and let's see if you can recognize it. The square root of 5 is approximately 2.23. When you add 1 to that, you get 3.236, and then divide by 2, and you get 1.618. Does that number look familiar to you? 1 plus the square root of 5 over 2 is equal to 1.618, dot, dot, dot. This is the number phi. That's why it's special. Alright, so if you think about this in terms of a problem like this, okay? This is a rectangle of sides length x and 1, okay? And there's a thing called the golden ratio, and a lot of painters have used this over time, that says there's this special line that you can put here, this special place where the ratio of the sides are equal. The ratio of the longer side of this rectangle to the shorter side, so this ratio, x over 1, the longer side of the rectangle to the shorter side, is equal to the ratio of the longer side of this rectangle, over here, the long side of this rectangle to the shorter side. Okay, so the longer side of this rectangle, that's 1, to the shorter side, x minus 1. There's a special place where that ratio is the same, and if you were to cross multiply here, you would have x times x minus 1 equals 1, which is x squared minus x equals 1, which if you subtract 1 from both sides, you get this formula. So that the x value that gives you that special ratio is 1 plus the square root of 5 over 2, or the number phi. So that's the golden ratio, and this is one derivation of it. So that's the quadratic formula, and let's talk now specifically about this part of the quadratic formula in here. Okay, that's called the discriminant. So that's where this word is coming from over here. The discriminant can help you answer this question: what are the types of solutions and the number of solutions that you get? So if you get a number that is greater than 0 for b squared minus 4ac, you're going to have two real solutions to the equation. And the graph of it will look like this. The places where the graph crosses the x-axis, the zeros, you see the graph crossing the x-axis twice. Okay, there's two real solutions. But if b squared minus 4ac is a negative number, so let's look down at this case, then you have the square root of a negative number, like we had in the other example, negative 20. So you get an imaginary number at the end as part of the solution. And so you don't have any real solutions, you have two imaginary solutions. And what the graph of that looks like is there's no place that this graph crosses the 0 line. Okay, there's no place that it crosses the 0 line. So you have two imaginary places that it crosses the 0 line, but in terms of the real plane, real numbers, x and y, it doesn't cross the axis. So there's no x-intercept. Then if it is exactly equal to 0, let's look at this formula. Negative b plus or minus the square root of 0 over 2a. If that's 0, this thing goes away. Plus or minus 0 is just 0. So you get negative b over 2a. That's one solution. There's only one solution to the equation if it's perfectly equal to 0. Alright, so let's use that fact to help us determine the type and number of solutions in this example. So all we're going to look at is the discriminant, b squared minus 4ac, the stuff that would go underneath the radical. And b is 6, a is 1, and c is 8. So b squared is 6 squared minus 4 times 1 times 8. That's 36 minus 32. It's a positive number, so we know we have this case. We have two real solutions. That's the type. The type of solutions are real numbers, and the number of solutions are 2. There are two solutions. Okay, so then let's use this to answer a really common type of question that algebra is used, that quadratic formulas are used for. So this is called a kinematic equation, and you'll see this if you take a physics class. But what it does is it models an object that is being influenced by gravity, the height of that object versus time. So we're going to suppose a player kicks a ball that has an upward velocity of 34 feet per second. So you kicked this up in the air, and it's going up at a rate of 34 feet per second. Feet per second. The function right here, h is equal to negative 16t squared plus 34t, models the height h in feet of the ball at time t in seconds. This coefficient, negative 16, is related to the acceleration of gravity in feet per second squared. This is your velocity. So if I had said he kicks the ball in the air at a rate of 40 feet per second, then the equation would still say negative 16 squared, but then it would say 40t. Now if I said you were standing up on something, like let's say you're on a cliff and you throw a rock down, this is you're throwing a rock down, and let's say you threw the rock at 10 miles per hour, well now it's going down, it's going with gravity, so the equation would be negative 16t squared minus 10t, because that's your speed, and it's going with gravity. But in this case, if you're throwing a ball up in the air, gravity's working against the ball, which is why it has a different sign here than here. So what we want to know is, will the ball ever reach a height of 20 feet? So we don't need to actually find the height of 20 feet. What we want to know is, if I was to plug 20 in for the height, would this give me a time, a real time in which this happened? So what we do is we rewrite this in standard form by subtracting 20 on both sides, and then calculate the discriminant, b squared minus 4ac. So we want to know, what is 34 squared minus 4 times negative 16 times negative 20. If this is a positive number, then yes, it will reach that height. If it's a negative number, then we're going to have an imaginary solution, which in real-world situations like this aren't going to be helpful. So let's see, what is 34 squared? Really big number, 1156, but is it bigger than 4 times 16 times 20? Let's see, 4 times 16 times 20, 1280. So we have a positive 1156 minus 1280. We get a negative number. This is less than 0. So we're in this case, no real solution to imaginary solutions. So will the ball ever reach a height of 20 feet? No, it won't. So I didn't kick it hard enough to make it reach 20 feet. This number, this b value, would have to be bigger. So if I had kicked it at 40 feet, then it would have been hard enough, because 40 squared is 1600, which is bigger than 1280. So it would have overcome gravity enough to go 20 feet high. All right, so that's one example of where you might use the discriminant. And that's all for this lesson.